Hello guys, in this video I'm going to show you how to solve course schedule. So there are n courses labeled from 0 to n minus 1. Each course can have some prerequisite courses which need to be completed before it can be taken. Given the number of courses and a list of prerequisite pairs, find if it possible for students to take all courses. So let's look at an example. Right here we given the total number of courses of 2. Right, there are 2 courses, and the prerequisite arrays contains subarrays of the course and its dependency. So in this case it means in order to take course 1 you have to take course 0 first, right? So it is obviously we can take all courses, right, in this case just by taking course 0 first, then course 1, right? So it's pretty clear for this example. But for the second one, we also have 2 courses, but the prerequisites we're given two subarray here. It means the course 0 depends on course 1 depends on course 0, and course 0 depends on course 1, right? So it kind of contradicts here, right? So in order to take course 0, we need to take course 0 first. But in order to take course 0, we again need to take course 1 first. So it contradicts. So we couldn't find it impossible here. We cannot schedule all courses. So actually this one is pretty much the same as our previous problem in this category, which is task schedulings. Here we just paraphrase it a little bit from tasks to courses, but the requirements is pretty much the same here, right? For the previous problem, we also need to check if it is possible to schedule all the tasks, right? This case we just call it differently. Instead of tasks, we call it courses, right? So for this kind of problem, where we have a lot of tasks or courses that depends on each other, and we want to find an ordering, right? An ordering. Then in this for these kind of problems, we're gonna use a topological sort, right? So I've explained very detailed in the previous videos how to do topological sort. So for this video, I'm not gonna go into detail about it, and we will wanna dive in code right away, right? So for this kind of problem, there's a couple steps maps to do, right? We need to build our graph, of courses, right? So using adjacency list, adjacency list, right? So for adjacency list, want to keep a map, right? A map where each item in the map will be a course, then that is mapped to a list of destinations, right? For example, in this case, course 2, course 3, right? So course 2 and course 3, in this case, course 2 and course 3 depends on course 1, right? So it means we must take course 1 first before these two. Well, beside that, when I build incoming maps, right? Which is a map also using a map, right? Where the key will be using a map, where key will be the cost, right? And the value will be number of dependencies, right? How many dependencies this course have in total, right? Or in another word, if we draw it out in a graph where each course is a vertex, then the number of dependency is same as how many incomings, right? How many incomings directed we have vertex, and what is that for? Come on, what is the term? Vertex and edge, right? Edge. So here is actually how many vertex that how many vertex that pointed to this, how many edge, how many directed edge that pointed to this vertex. So we need these two, right? And after having these, wanna keep an initialize a sources queue, right? Sources queue that keeping sources queue that keeping all the vertex, all the courses that have no dependency. Okay, So we also want to initialize an ordering, right? So we'll try to build. The idea is we try to build the orderings of courses, right? So the course with no dependency will be put to the orderings first, right? So by doing so, gonna try to build our orderings. So if our orderings size is equal to number of courses, means we can schedule all courses, right? So you need the ordering as a heap, right? Sorry, it's already I'm gonna push to the orderings, and gonna loop, right? Here this loop take one course, right? out of the sources, out of sources queue loop as long as queue is not empty. Okay, take one course out of the source queue, add to ordering, right? So again, queue contains all the courses that had no dependency, right? So we take the course out, put in the orderings, right? Add to the orderings, and after that, gonna update, right? Update the incoming map. Add courses that the course out here is pointing to, right? Gonna decrease the incomings of those courses by one, and if it reaches 0, gonna add to if it reaches 0, then it's gonna be the next candidate to put in the queue, right? Put in the queue. Okay. Finally, when we exit the loop, mean the sources is empty now, so we can return here. Okay, so that's it for the structure. Let's try to implement it. We need a graph, right? Const graph is a map, and we need a incoming also a map, right? Okay. Number of courses, right? Gonna initialize a map first. So gonna iterate through every course, right? Of number of courses is a number, so I'm gonna do a little check here. Array of num courses. This will return, for example, array of 3, right? So it return array of 3 empty items, and I'm gonna use keys, right? So gonna iterate to the key, which is from 0 to num courses minus 1. Right? So course here will run from 0 to num courses minus 1, which is what we have, or which is what we need. So for every course, wanna initialize with wanna set the course. Here the graph will be contains key values. Key will be the course, and value will be an array of the destination courses, and incoming I'm gonna set the course. Initially it's 0, right? How many dependency this course have? Because has, right? Incomings, okay. Okay, initialize sources to keeping all calls that have no values. So, forgot. We need to iterate to the prerequisites to build our map. Right? Here is just initializations. So for let, we'll look through the subarray, right, of prerequisite. This will be an array of subarray, right? Each subarray will be this structure into the desk, right, and the source, course, and user destinations, right? So graph, I want to set here. I'm gonna get the source, right? This will return an array of all the list of destinations. I'm gonna add push the current destinations into the list, right? Also incoming, update the incoming to the desk, right? Update to whatever it is right now. That's one. Okay. Okay, we need on the sources is a queue. I'm gonna use a array, right? And cons ordering is on its own right. I want to initialize the sources with all the costs that has no incoming, right? So in order to do so, I'm gonna iterate to for let of let's say of incomings, I'm gonna use entries. Right. Here will be key and value, right? Key is cost, and value will be number of dependency. Okay. So if the number of dependencies is equal to 0, I want to add this one to the sources, push cost. Okay. So we start to loop here, start the loop to build the orderings, right? So as long as the sources is not empty, get into here, get inside, right? Take one cost out, which is on cost out equal to sources is q. So because here we use push, right? We push to the end, and we need to remove from the head of the array, which is sources dot ship. Okay. Take the cost out, add to the ordering, push. Okay. Update incomings map causes that the cost out is pointing to. Okay. So after this one is out, every cost that this cost is pointing to, we need to update. So I want to use so how to know which courses this one is pointing to. Anh trước đang bận ạ. So how to know that? I want to use the graph, right? It is actually we can find in the graph. So for what? For that key value in the graph, right? Look for key value in the graph. Key will be not. We can use so we can get the destination of one cost, right? So graph get key is the cost out. This will return a list of destinations coming from cost out, right? So I'm gonna look for every destinations, right? Coming from here. I'm gonna update this, incomings to that by one. So incomings to destinations, set destination cost destinations, right? Equal to a new value, which is whatever it is right now. -1. Okay. Okay, if which is 0, put in queue because it's the next candidate to process. So if incoming get destinations, if there's no dependencies, then I'm gonna add it to the sources, push destination. And if we exit here, it means there's not thing in sources. Then we can check by we can check if we can take all courses by comparing the orderings, right? Size, return orderings, length with the number of courses. So if the number of courses, total courses, equal to the orderings that we've built, means we can take all courses. Okay, let's try to run the test. 16 3.1. Whoops, cannot push undefined. Why graph gets also undefined here? Let's see. $31 here. Prerequisites for now. Use entries. Right. Oh no. I'm not sure. Prerequisites is a array. Right. So we look for every item is array. Destructuring it now. What's wrong here? Lack of is in map. Okay. Set the course. No, right. Let's be keys. Okay, it works. But let's check our previous program. Is there anything that is missing here? So the code is pretty much the same as you can see. Right. So that's it for this program. So thanks for watching. See you in the next video.